Hi all, this is Priyadashni working as an assistant professor in the Department of Artificial Intelligence and Data Science. Today we are going to see into the topic critical section which comes under process synchronization of operating systems. In the previous lecture, we saw what is process synchronization. So what is process synchronization? When the concurrent process are trying to access the critical section part, that has to be synchronized. When a concurrent process is accessing some variable, all other process should not access those critical section segment of code. That is called the process synchronization. Definitely, when a concurrent process is executing the system, there would be data inconsistency. So, in order to avoid data inconsistency, we have the process synchronization. So, now let's see what is critical section problem. Before going to see what is critical section problem, let's see a story. So, there was a mother. She had three children. So she kept a jar full of chocolates and she told the children that only one should take the jar and take the chocolates and distribute. But when the mother went outside, the chaos happened that all the three was wanted to access the jar and take the chocolates, and unfortunately the jar was broken. So what did the mother does was she shouted at them and she told that when one person is entering into the room which has the jar full of chocolates, the other two person should be waiting outside. That is, she told that there should be a red flag when a person is inside the uh, room. And the other two person should be waiting outside. So when this is made, there would not be any chaos in the home. So the same thing is applicable to the critical section problem. Consider a system consisting of n processes. So P0, P1, P2, etc. are the processes in the system. So all these processes will have a segment of code called critical section. So in the previous lecture, we saw the process synchronization. In the process synchronization, the critical section variable was counter variable. So when the process is in the critical section, the process may be manipulating it. So manipulating the counter, for example, here manipulating the counter variable. So if the process is in the critical section, it may be changing the common variable, or it may be updating a table, or it may be writing a file and so on. So when a process is in critical section, the manipulation will be done. At this time, we should ensure that no other processes will be executing in the system. That is, when one process is executing in its critical section, no other processes is allowed to execute in its critical section. No two processes in the critical section will be at the same time. So this is the protocol that the processes can use to cooperate. So this is the general structure of a typical process. So each process has four types of sections called the entry section, critical section, exit section, reminder section. So what is entry section? Entry section is nothing but a process when it wishes to enter into the critical section, it has to make a request. So making a request is called the entry section. Then when the entry section in the entry section, if the process is made to go to the critical section part, then here the section of code will be the critical section part, that is the counter. For example, the counter variable will be in the critical section part, so it can manipulate those data. And once the critical section variables are accessed and it has updated, then the process may come to the exit section. So exit section is nothing but a section of part where the critical section is come outside, that is the red flag has been kept down in the previous story. After this, the reminder section, wherein the reminder section of the code will be accessed. So this is the typical example of a process or the general structure of the process. So there are four sections: entry section, critical section, exit section, reminder section. So let's see what are the critical section requirements to solve when a problem is in critical section. So the first requirement is called mutual exclusion. As we all know what is mutual exclusion, only one process at a time can be inside the critical section. Remember, only one sibling will be inside the room full of chocolate. The next condition is called the progress. So whenever the critical section is free, the system has to follow the next process to proceed without any unnecessary waiting. In the previous case, if all the siblings are outside, if one sibling needs to access the room, then he has to go inside the room, or all the three siblings has to make a decision that whom is going to enter into the room full of chocolate. The next condition is called bounded waiting. So there is a limit to how many times the other processes can enter their critical section. That is, we cannot allow all the one sibling to enter into the critical process simultaneously. We have to have a limit. We have to have how many times he has to enter. So this three requirements should be satisfied in order to solve any critical section problem.